Hi, welcome back to OCR MEI past paper walkthrough. Today we're doing Core 3 2017. So let's get started with section A. Question 1 is just simple differentiation. 1 over, in brackets, 5 minus 2x cubed all squared. So for this question you do want to use the chain rule. And in order to do anything realistically, we need to put this into index form, which is 5 take 2x cubed all to the power of negative 2, because 1 over is just negative power. So now we do the chain rule, which takes the big power down to minus 2 lots of 5 take 2x cubed. Minus 2 take 1 is minus 3, then multiply by the differential of the inside, which should give you a negative 6x squared. With that, the two negatives becomes a positive. 2 times 6 is 12, so you get 12x squared times 5 take 2x cubed to minus 3. And that is sufficient. You can put this into a fraction form, but it really doesn't matter. That would gain you 3 marks anyway. Question 2, we have a function fx equals to mod of x for this domain. And so we need to sketch the graph of gx, where gx is 2 take 2 function x. So let's start with a curve or a 2D dimension, x and y. Then we want to sketch gx, and we know at the y-intercept we have a value of 2, because fx at naught is just 0. So we have a point of height plus 2. That looks bad, so 2. And we know it is a negative function of x, where x, we can tell, if you've seen enough of this mod, you should be able to tell that it's just a V-shaped graph, centered origin, with gradient 1 on minus 1 on the negative domain and plus 1 on the positive domain. With that said though, if you can't do mod, I suggest you draw just y equals normal x, which everyone should be able to do. It's just a straight line through the origin with gradient 1. But then the mod essentially flips everything negative positive, so instead of having something down here, you flip it up to the positive domain and take this off. Then you'll get the mod x graph. Now we have a negative value for the mod x graph, which means that we want to flip the whole thing down, which should give us something along the line of this. And we have 2 times the function, which means that the gradient should double, which means the negative 1 gradient turn into a negative 2 gradient, and this plus 1 gradient goes to a plus 2 gradient, and so it should kind of horizontally squished together. And now we just need to transform this up by 2 into the proper intercept, so you should get something along this line, except the fact that we have a domain limitation, so we need to take off the negative values. And label this should be plus 1, and this should be minus 1 as intercepts. And so that is question 2. Question 3, part 1, we need to find the inverse function of x, inverse f rather, and state its domain and range, so where fx is ln natural log of 1 take x. So let's start by writing down the equation fx equals to natural log 1 take x. Then we want to kind of rewrite the variable in the opposite way, where fx becomes x and x becomes the inverse function of x. Then we can just do a rearrangement. E to the x is 1 take arc fx, and that means that our fx is 1 take e to the x. With that information, we can now state domain and range. So from the domain, from the range, it's already defined by the question. So range has to be in between -1 and 1, and using this information we can kind of calculate the permitted x values. So x, if you do arcf is 1, then you get natural log of 0, which is undefined. And if you put -1, then you'll get 1 take -1, which is natural log of 2. Natural log of 2, and this is x has to be less than natural log of 2, and it can go to negative infinity as far as the value is concerned. And yeah, that's it for this question. In part 2, show that fx plus f of minus x equals to fgx. So let's start with f, just writing down fx and f of minus x. Natural log of 1 take x add natural log of 1 take negative x is equal to natural log of 1 take x plus natural log of 1 plus x. And if you know your log rules, you can put them together to a big log, natural log of 1 plus x, 1 minus x. And by the law of difference of two squares, you get 1 take x squared, and x squared is actually gx. 1 take gx, which is just f of gx. So that is proven. Question 4 is implicit differentiation. So let's try this out. Implicitly differentiating this whole expression by x will give us 2/3 lots of 3x to the minus 1/3, because you take 1 off the power, add dy dx of 2 y to the minus 2/3 multiplied by the power drop, which is 1/3, equals to 7 differentiated by x gives me nothing. And do some cancellation here and rearrange such that the x term is on the right, gives us minus 2x to the minus 1/3 is dy by dx of 2/3 y of minus 2/3. And by dividing at this end, this term rather, we should get dy by dx is minus 3x to the minus 1/3 y to the 2/3. And that is the first part done. Hence find the gradient of the curve at point with coordinate 1, 8. With basically you just sub in. If x is 1, then this whole term is just 1, so you get minus 3. If y is 8, then 8 to the 2/3 is just 4, so you get minus 12 as your gradient. Question 5, an exponential kind of decay kind of question. Part 1, write down the initial temperature and the boiling point of the liquid, where the temperature is defined as 10.5 plus 69.5 multiplied by 1 minus e to the minus kt, where k is a positive constant and t is the time in minutes. So if t is 0, then it's essentially 1 take 1, which gives us 0, so the 69.5 term is not contributing anything, which means that theta naught initial is just 10.5 degrees Celsius. And the boiling point of the liquid, which is as t tends to infinity, will give us 1 take e to the minus infinity, which is 1 minus 0, or just 69.5. So 10.5 plus 69.5 give us that theta boil is 80 degrees Celsius. So that's part 1 done. For part 2, after being heated for 1 minute, the liquid has temperature of 30 degrees Celsius, and we need to find the value of K. So let's give this a try. When theta is 30, then the equation is as follows: e to the minus k, t equals 1, which means that the exponent is just minus k. With that, we rearrange to get 19.5, 69.5, 1 minus e to the minus k. Divide both sides by 69.5, we get 19.5 on 69.5. 1 take e to the minus k. And for the purpose of this kind of teach through, I'm gonna go with full algebra mode and just plug things in by the end. You can feel free to do everything in terms of actual raw decimal numbers, especially when you have your calculator handy, then it's not that big of a deal. That would give me a natural log of 1 take 19.5 on 69.5, which means that k is just negative ln 1 take 19.5 on 69.5. Sorry for writing quite badly here. That should all give you 0.329 as a value, and that would be the value of k. Then finally we need to find how long does it take for the temperature to reach within 1 degree of the boiling point, which, because it never reaches the boiling point as t needs to get to infinity. So 1 degree from the boiling point of 80 is 79 degrees Celsius as our target temperature. So 79 is equal to the equation 69.5 1 take e to the minus kt. And just let's rearrange this to get 68.5 on 69.5 is 1 take e to the minus kt, and e to the minus kt is just 1 take 68.5 on 69.5. Then if we take natural log of both sides, we get minus kt is natural log 1 take 68.5 on 69.5. Then, using the previous value that we have on k, you can either use the decimal or use the natural log. I'm just going to write the natural log version out. T times, because negative k is just positive natural log of this thing, so I'll just do both steps at once. 1 take 19.5 on 69.5 equals to natural log of 1 take 68.5 on 69.5. Then we just need to divide both sides by the natural log on the left to get natural log 68.5 on 69.5 all over natural log of 1 take 19.5 on 69.5. This fraction cannot be simplified just because of log doesn't really do multiplications. But if you plug everything into the calculator, it should give you 12.87, and that would be the closest minute 13. So that will be your answer. Question 6 is a simple proof. You can either use proof by counterexample or just proof by contradiction. But for the purpose, I'm just going to prove it by showing that in order to get a polygon with internal angle 155, it cannot be regular. So let's start with 180 and 180n take 2 as the internal angle of the polygon. That's the sum of every internal angle. If that is a regular hypothesis, you do need to write that down, by the way. If 155 is an internal angle of a regular polygon, then 180n minus 2 equals to 155n, because sum of the internal angles, which every one of them is the same, should give you the sum by definition. Then we can expand everything and calculate. With that said, 180 and take 360 equals to 155n, and by rearranging we get 360 is equal to 25n's, and in this case if you plug it into the calculator, then you get n is not an integer. which means that this cannot be a regular polygon. The value is between 12 and 13, I believe, and so you should be able to also say, hypothesize if n is 12, then you get a certain internal angle that is smaller than 155. If n is 13, then you get something that is larger than 155, and so 155 is not. That is the counterexample one, and both way works. Question 7 is kind of implicit-ish, but not quite. It's just differentiation, really, and parametrics, I guess. So, first part, express x and dx by dy in terms of y. So first of all, let's rearrange for x. Let's take the inverse of the inverse sine, which gives you just the sine. So sine both sides. Get sine y equals to half of x. And so x is just 2 sine y. Nothing surprising there. To find dx by dy, you differentiate by dy, which looks kind of different, but in a nutshell, it's just the same thing that we have done, except it's dy instead of dx. So it's just simply 2 cos y. There's no trick to this whatsoever. Then part 2, we've got a point moving on the curve with respect to time. When x is 1, dx by dt is 2. Find dy by dt. So dy by dt, we know it has to be dy by dx multiplied by dx by dt due to chain rule, because the dx's can cancel. But then we do not really know dy by dx. However, we do know dx by dy, and they have a reciprocal relationship, which means that it's just 1 over the 2 cos y multiplied by dx by dt, which is given as 2. With that, cancel the 2's, you get 1 on cos y as your value. And when x is 1, that is the that instant, we need to find the value of t that corresponds, the value of y that corresponds to x is 1, so we just sub in values. We want to find y, so y equals to arc sine of a half times 1 is just a half, which should give you in radians pi on 6, or just 30 degrees if you do use angles in degrees. It's personal preference. No one really cares if you use either one, they work the same way anyway. With that, you sub in to cos y, and you should get 1 on root 2 on root 3 as your result. And yeah, that's this question, the first, this is this question done. With that being said, section A is done, and it's relatively tricky in terms of a C3 paper. Especially with the domain and ranges, there are a lot of things that can catch you out, like when it comes to a defined range rather than all possible values that have a meaning. Then the more you look at the question, then the less likely that you're going to trip up. But other things like the implicit differentiation should be relatively straightforward. next time I'm gonna get this section B sorted by today, and hopefully as I'm uploading section A, then this will be processed. Anyway, I'll see you next time with section B, and good luck with the exam tomorrow, or whenever you're watching this.